So probably 2 or 3 more tutorial sessions after today. I think 2 tutorial sessions will work out. So in case if you still have any doubt in any way, please gear up yourself. Okay. So we have discussed till question number 3 in assignment sheet 7, right? And today we need to discuss. Yes, yes. So today we need to start with question number 4, the Euler's problem and Runge-Kutta method, right? So have you tried doing these problems? Okay, let me ask question by question then. Have you done question number 4? Are you clear with question number 4? They are asking you to find the explicit solution for yn, which can be found out by the Euler's method, which is nothing but y of n plus 1 is equal to y of n plus h times fxn by n, right? And they are asking you to find the error bound for yxn minus yn. And I think you guys must be aware about the error formula in case of Euler's method. There is a direct error formula, right?
सर
Yes.
सर जो इसमें एक्सप्लिसिट फॉर्म फाइंड करनी है ना वो नहीं हो रही, एच में कॉम्प्लिसिटी आ रही है, फिक्स नहीं है कि यही आ रही है.
Okay, so what you might have done is y of n plus 1 is equal to yn minus hyn square, right?
यस सर.
So you want to find it in terms of y naught, is it so?
यस सर.
Let me see, because as far as I recall, I haven't solved these problems.
सर वाई नॉट गिवन है तो जो फॉर्म आएगी वो एच में ही आएगी.
Okay. But it will get more and more complicated, right?
यस सर.
Because for example, if we start with y of 1, it will be nothing but 1 minus h. But if we go to y of 2,
यस
it will
सर.
go to 1 minus h minus times h times 1 minus y 1 minus h square. Is this the
यस
trouble?
सर. नो.
And clearly I can't see any pattern in h here.
हाँ सर यही प्रॉब्लम है, इसमें एच का कोई पैटर्न नहीं बन रहा, फिक्स नहीं बोल सकते ये एक्सप्लिसिट फॉर्मूला होगा.
Right. Okay. Okay. Have you tried doing it for 1, 2, or say y1, y2, y3? So can you tell me what is y1, y2, y3 coming to you?
सर y1 1 minus h.
Just a second. Number 4, right?
Yes sir.
Y1 is coming to be 1 minus h. Y2 is equal to
1 minus h into 1 minus h plus h square.
okay, and y3 will be 1 minus h.
सर ये कैलकुलेट नहीं कर रखा एक्सप्लिसिटली डायरेक्ट।
Okay.
सर फिर मैंने yn+1 से भी अपोजिटली स्टार्ट किया था, उससे भी नहीं बन रहा था, मतलब yn+1 से स्टार्ट करके फिर yn-1 की वैल्यू पुट करके।
Okay, let us see here. It will be 1 minus h times 1 minus h plus h square times 1 minus h. So it is coming out to be minus h cube plus h square plus h square plus 2h square minus 2h and plus 1, right? And if I go to y3 for the time being, suppose, then it is 1 minus 2h plus 2h square minus h cube minus h times 1 minus 2h plus 2h square minus h cube, right? The whole space. So it is coming out to be 1 minus 2h plus 2h square minus h cube times 1 minus h plus 2h square minus 2h cube plus h power 4. Have I done something wrong here?
No sir.
Yeah, right. So this is the form coming, right?
Yes sir.
Okay. Just a second, let me write y2 also in this form. It will be 1 minus h times 1 minus h. It's 1 minus h common. 1 minus this is what you are getting here. So at max what we are able to say is this only, yn 1 minus h times yn. We are not getting anything else here because clearly there is no such pattern coming out to be. So let us do it in another form. That is 1 minus 2h plus 2h square minus h cube. You can write it as 1 minus 3h plus 3h square minus h cube plus h minus h square. So it is nothing but 1 minus h whole cube plus h into 1 minus h, right? So 1 minus h common, 1 plus 1 minus h whole square. So h plus 1 minus h, right?
Yes sir.
And if we start working out with this one, then our y3 was again, first of all we will have y2 as it is, so we will surely have this thing 1 minus h plus 1 minus h whole square, and minus into 1 minus h plus 1 minus h whole square. So it is 1 minus h plus 1 minus h whole square into 1 minus plus h square plus 1 minus h square. Now to be 1 minus h plus 1 minus h square 1 minus h square minus h times 1 minus h square minus h cube minus h square times 1 minus h whole square.
सर
Yeah,
सर लास्ट सेकंड लाइन में आपने h प्लस h स्क्वायर लिखा है, वहां पे h माइनस h स्क्वायर नहीं आएगा?
यहाँ पे
लास्ट सेकंड लाइन में नहीं
यहाँ
है।
पे okay, I'm sorry, it will be h minus h square. So it will be plus here and plus here, right? Let us try to solve this more than it is 1 minus h square minus h times 1 plus h square minus 2h plus h cube plus h square times 1 plus h square minus 2h. I am calling it a for the time being. Okay, so it is a times 1 minus h square minus h cube plus 2h square plus h cube plus h square plus h power 4 minus 2h cube, right?
यस सर।
This get cancelled out, this get cancelled out. So we are left with a times 1 minus h plus 2h square minus 2h cube plus h power 4. So I click 1 minus h common plus 2h square times 1 minus h plus h power 4. Basically h power 4 plus 1 plus 2 square into 1 minus h. One thing is this. Okay, let us see. Are we getting any pattern here? Initially we were getting 1 minus h, then we got 1 minus h and h plus 1 minus h whole square. Then it is coming as it is. We will solve this also once more. We are getting square. That will not help us, right? That time is not helping us. So leave that for the time being. So we are sure that our calculation is fine up to here. But if I may want to make a pattern here, if I write it like this, x square plus 1 plus 2x whole square part 4 plus 1 plus 4x square plus 2x square plus 4x plus 4x cube. H part 4 plus 1 plus 6h square plus 4h cube plus 4h. So if I want to write it here, it is plus 1 part 4, h part 4 plus 1 plus 1, and then plus 6h square, so minus 4h square plus 4h cube, so minus 6h cube plus 4h minus 5h plus 1 part 4 minus h 6h cube plus 4h plus 5. Even this didn't help us. Okay, I will try to find an explicit formula for this. Give me some time. Till then, let us discuss other problems. We have some time left in the tutorial. We will discuss here itself, or I will share a solution for this. Okay.
Okay, sir.
Okay. So coming to question number 5. Is it done? So if we apply Euler's method in question number 5, what approximation we will get?
0.
So any y1, y2, any yn we will get 0, right?
Yes, sir.
Question number 5, yn is coming out to be 0 for all n, in which is indeed a solution. If I just give you two things as y prime is equal to 3 upon 2, y to the power 1 by 3, and y of 0 is equal to 0. If I just give you this much information, then this is anyway a solution. Y is equal to 0 is a solution, right?
Yes, sir.
But we know that the solution to this equation is also y is equal to x to the power 3 by 2. So the question is asking why our approximation or approximation is nowhere close to this solution. So did you got the reasoning? Okay, if you don't have the reasoning with you, it doesn't matter in this question, because it is just asking you to show that the Euler's method is not converging to solution number 2. if I say solution y is equal to 0 is my first solution, so it is just asking you to prove that our approximation is not converging to solution number 2. Okay, but if I just ask you for sake of the explicit, you must have read the existence and uniqueness theorem for IVP. So it is a given OD which is of first order, and you have given one initial conditions with you, but still you are getting two solutions. So why is it so? Which property of existence and uniqueness is getting compromised here? Are you getting my question? Okay, let me this question. Given OD y prime is equal to 3 upon 2 by the power 1 by 3 with initial conditions y at 0 is equal to 0 has two solution in neighborhood of 0, of course. Zero given by y1 of x is identically equal to 0 for all x, and y2 of x is equal to x to the power y2 for all x y. Can anyone tell me the reasoning for this? Am I audible?
Yes, sir.
So can you please tell me why is it so? Existence and uniqueness say na ki we will have exactly one solution, right?
Yes, sir.
So, but here I am giving you two solutions. So existence and uniqueness theorem must have compromised somewhere, right?
Yes, sir.
Otherwise, it is the counter example for the old theorem. So, have you seen like which initial condition or which condition is getting compromised here? So,
Sir,
can you? Yes,
y
yes,
1 by 3 is not Lipschitz.
yes. Y to the power 1 by 3 is not Lipschitz continuous.
Yes,
But
sir.
you can see that y to the power 1 by 3 is not differentiable around 0,
0.
right?
Yes, sir.
So, are we clear with question number 5?
Yes, sir.
What about question number 6?
Sir, what is delta here?
Delta should be the error. You have some formula for the error bound, right? The global truncation error, it was, I might be wrong here, it is somewhat like this. E to the power n x minus x naught minus 1, something of this sort, right? So if I want to find my error at any point x, it is my e of x. So this is how you give the truncation error, global truncation error. You have seen that local truncation error was of order h square, and then global was of order h. And there you must have seen a formula of this sort. where m was must be the upper bound of f double prime x supremum, and L is the Lipschitz constant for f. Lipschitz constant of x in second variable, of course. Have you seen such result?
Yes, sir.
So what things you have? You want to find the error at x is equal to 5 now, right?
Yes, sir.
And you must have some L with you. So if I see your f of x comma y is nothing but 1 minus y plus x. So if I go with this, fx y1 minus fxy2, it is nothing but mod y1 minus y2 only, which is anyway less than some a times mod y1 minus y2 for all a strictly greater than 1. So you can take for, in particular, I can take a to be equal to 2. So this a is nothing but my L, right? So you have L with you, which is equal to 2. You can find the double derivative.
सर A1 भी ले सकते हैं ना?
नहीं, 1 नहीं ले सकते, because what we do in Lipschitz continuity, if I say that mod fx minus y is less than k times mod x minus y, right? What I want is mod fx minus fy is less than k times mod x minus y. If I am using this definition, then I need k to be strictly greater than 1. For some books refer less than equal to k times mod x minus y. So it depends which definitions are you following, or which definition have ma'am told you.
सर लेस देन इक्वल टू ही बताया.
Okay. So if less than equal to, you can anyway take L to be 1 also. Yeah, made a mistake here, sorry. It will be y double prime x, right? Because if I take f double prime x, it will be 0 only. So you have m with you, you have L with you, you have x minus x naught, it is will be nothing but 5, because x naught is anyway 0, and you have the error with you 10 to the power minus 6. So you just need to find that. Clear?
Yes, sir, clear.
Okay. Okay, coming to the question number 7, they are asking, they are giving you the same OD with the same initial condition, I suppose, yes, but with a different interval, of course. And they are saying that midpoint method, modified Euler's method, and Hume's method will give the same approximation. Okay, I think there should be some misprinting or more printing here. Modified Euler's method will not be here. So the question will be midpoint method and Hume's method. Please correct it in your sheets. In the question, they are asking about Hume's method and midpoint method. So let me write the formula for both of them. For the Hume's method, approximation comes like this: yn plus 1 equals yn plus x upon 2. Okay, let me make it k, because n is our number of iterations. f of xk comma yk plus xk plus h comma yk plus h times f of xk comma yk and midpoint method y of k plus 1 equals y of k plus h times xk plus h by 2 comma yk plus h upon 2 xk comma yk. So for these two methods, we want to show that for f of x comma y equal to 1 plus x minus y. So if I take it as yh, if I write it as ym, so yh k plus 1 equal to ym k plus 1 for all k. So that's what we need to show. So please write down modified Euler's method, because you see that in modified Euler's method, if I write modified Euler's method k plus 1, it will be yk plus h f of xk comma yk plus f of xk plus h comma yk plus 1 only, right? So something of this sort. So basically it is an implicit method. And these two are explicit. Fine. So have you verified it for Hume's method and midpoint method? They are coming same. Have you verified it for both the cases?
No, sir.
Okay. Let us do it. So can you do it, or shall I do it here?
Sir, we can do it.
No, sir, we can.
Okay. So shall it be left as an exercise? It is very easy. You just have to substitute f of x comma y to be equal to this, and it will come for sure. And modified Euler's method will not be there because it is an implicit method. So anyway, if you just do these type of calculation, then you will have 1 plus, or say minus, okay, 1 plus some h times of, the formula will be something like this, yk plus 1, and here some formula in yk for this. But here the coefficient of yk plus 1 is nothing but equal to 1. So you can remove modified Euler's method from the question as of now. Fine. Shall we proceed to question number 8?
Yes, sir.
Okay. So the question 8 for difference method can not have local truncation error of order h cube. So have you gone through the derivation which ma'am must have taught in the class for, say, Range-Kutta method or Euler's method, the error derivation or local truncation error derivation? So she must have proved in the class that if you go with the Euler's method, then you are having local truncation error of h cube, And if you are going from for the second order Runge-Kutta method, it is coming out to be of h cube again, something of that sort. Have you done those calculations? Have you seen them?
Yes, sir.
Yes, sir.
So if you see, I'm first of all, let me give a basic difference here. If you see there, what you were having y of I plus 1, if I say for the time being, let me take Hume's method only. So y of I plus 1 was equal to y of I plus h upon 2 f of xi comma yi plus f of xi plus h comma yi plus psi k1. Okay, where k1 is my this h f of x1. Okay, let's make it ki f of xi comma yi. Okay. So if you see, you have one h variable here. So that is why when you were doing all the subtraction, what you were doing, you were writing this thing and you were finding y of xi plus h by Taylor series. So it was nothing but y of xi plus h times y prime xi, which you were writing as f of xi, and then you were doing h square y double prime of xi and plus h cube y double, say y3 of psi, right? And here you were using f plus fx plus f time fy, something of this sort you have done, right? And then you were just subtracting these two equations, and these yi and yi were getting cancelled, and this h times fxi was somewhere getting cancelled with here. Okay, initially what you were doing in Runge-Kutta method was you were writing yi plus 1 to be equal to yi plus xi1 time k1 plus xi2 time k2, something of that sort. And instead of those xi1 xi2, they are giving you a1 a2. Okay, but with those xi1 you were getting some h there, this h. So that's why the regulative was coming to be order of h cube. But since in our problem, but they are giving y of I plus 1 is equal to yi plus a1 f of xi comma yi plus a2 f of so on something. So you are not having that extra h here. So at max what you can get is order of h square locally. Are you getting my point?
Yes, sir.
So now if you solve this a1 a2 and you compare with this equation by 1, so what you can find, I will get cancelled, and we want to finish out off with powers of h, so we have to do f of xi to be say 0 or something. Okay, so let me do this here. So it will be so if I compare it to the general equation, if y of k plus 1 is equal to pi k plus h f of xk by k h, and then local transitionality k plus 1 was given by y of x k plus 1 minus y of xk plus this term, but with h. But if we are going with our term, So what will be my local truncation? It will be y xk plus 1 minus y of xk plus a1 times f of xk comma yk plus a2 times f of xk plus alpha 2 comma yk plus delta 2 f of xk comma yk. Now using Taylor series here, what we will get is y of xk plus h times y prime xk, which will be nothing but f of xk plus some order of h square minus y of xk plus a1 of xk yk plus a2 and something. So this will get cancelled. So even if I want to have order of h square, then I have to have a1 and a2 to be 0. And still I might not get order of h square. Then also I will get at max order of h. If a1 is equal to 0 is equal to a2, then only I will get order of h. I can't even get order of h square here. You can see directly. Or we should solve this one also. Okay, let us solve the second thing also. Maybe we get at least order h square, because since we are just compromising on one power of h, so we should get order of h square. Delta 2 xk comma yk. So if this is the case, so let us forget about a2 first. So if I apply Taylor series here, so I will get f of xk comma yk plus alpha 2 times fx plus delta 2 times f times fy plus order of h square, right? There will be some h also. So if I go with this and substitute it here, then again I am getting tk plus 1 is equal to a1 plus a2 with a negative sign f of xk comma yk plus में h f of xk comma yk minus this thing alpha 2 f of x minus delta 2 times f of y. There will be some a2 also, a2 plus order of x square, right? Okay, maybe I was just writing, I was not making things understandable. Is this thing clear? Yk, if yk plus 1 is equal to yk plus something h times whatever approximation we are choosing, Newton's method, midpoint method, or any method. So our local truncation error is given by star, right? This is by definition.
Yes, sir.
So if my approximation y of I plus 1 is given by this y1 by I plus a1 times something plus a2 times something, then my local truncation error tk plus 1 will be y of xk plus 1 minus y of xk plus whatever the approximation is given to us, right?
Yes, sir.
So here what I have done is I have applied Taylor series on y xk plus 1, because it is nothing but y of xk plus h. So it will be y of xk plus h times f of xk, because it will be h times y prime of xk, which is nothing but f of xk comma yk, plus some order of h square, right? Minus y of xk plus a1 fxk yk and plus this term. right? So let me do this. Do this. Till here is it fine? Till this step,
Yes, sir. Fine.
right? So now we are applying Taylor series for two variables. So we are getting this thing f of x k y k alpha 2 times fx h plus delta 2 f times f by h, right? So I should have written it in this manner: h time alpha 2 fx h time delta 2 f fy plus order of h square, right?
Yes, sir.
So if I substitute it in our given truncation error formula, I'm getting this sort of equation. So anyhow, if I substitute any value of a1, a2, some anything, at max what I can do, I can make this 0 and somewhere I can make this 0, which is also very difficult because it is depending upon f now. But for each f, if I know f, I know fx, I know fy, I can probably make some changes on alpha 2, a2, all these things to make this 0, right? But at still, what I'm getting order of h square. Is it making sense?
Yes, sir.
Okay. Shall we proceed to next question? Shall we proceed to question number 9?
Yes, sir.
So have you tried doing question number 9? Okay. Are you even aware about Hume's method of order 3? Like what is the formula? Are you aware about Hume's method of order 3 formula? The approximation formula?
No, sir.
Okay, let me write that. Anyway, you can find it from there. The equation which is given to you, y of I plus 1 is equal to yi plus something. Because they are asking you that if you have the formula with you, then you can write it in this manner. So let me write the formula for you. It is y of I plus 1 equal y of I plus 1 upon 4 h time f of xi comma yi plus 3 upon 4 h times f of xi plus 2h upon 3 comma yi plus 2h upon 3 dot. So it is in continuation here f of xi plus h by 3 comma yi plus h times f of xi comma yi. So this is the formula. So what they have done, they are writing k1 to be h of fxi comma yi. So your y of I plus 1 will reduce to yi plus 1 upon 4 h. Okay, we will not have h here. Now it will be just k1 plus 3 upon 4 h times f xi plus 2h upon 3 comma yi plus 2h upon 3 dot. So it is product f of xi plus h upon 3 comma yi plus k1. And now from here you can write your k2 to be this second term. So f of h times, of course, f of xi plus h by 3, comma yi plus k1. If I write like this, then y of I plus 1 will, of course, will be 1 upon 4 k1 plus 3 upon 4 h f of xi plus 2h upon 3, comma yi plus 2h upon 3 k2. And if I write this term as k3, then yi plus 1 is equal to yi plus 1 upon 4 k1 plus 3 k3. This is what you were about to prove. So the thing is, you must be knowing this formula with you. I don't know why it is not known to you. If it has been given in the assignment, then I suppose that you must be known to this formula. But now is it making sense? Okay, H will not be here because we have already considered H here. Is it fine?
सर
Yes.
सर अगर एग्जाम में आ जाए ये क्वेश्चन तो एच क्यू ऑर्डर एच का तो हमें करवाया नहीं क्लास में, तो सर ये फॉर्मूला सर आपने अभी जो फॉर्मूला लिखा है ये नहीं करवाया क्लास में.
Yes, star, right?
यस सर.
Okay, so if this question comes in the exam, then I think okay, I will ask ma'am about it why she hasn't written this formula in the class. Because see, if something is getting asked in the question paper or in the measure, then it must have been taught in the class. In the assignment, she may suppose that okay, you can Google like what is the formula for Newton's formula for order 3, and then can do these things. But if it is coming out to be in the exam, don't worry, it will not come something from out of the box. You must have been taught some formulas there. So what you are supposed to recall or remember when coming to the exam, all the second order Range-Kutta method, say whether it is midpoint method or general Range-Kutta method or Newton's method. So all these three are nothing but second order Range-Kutta method, right? So these some formulas you must be aware about, you must remember them. So if something is coming out in the paper, so it will be from them only, which has been already given explicitly in the class. The formulas which have already been discussed in the class explicitly, because you can't write Hume's method of order 3 from your own. That is completely understandable on our part also, because you are not even aware what is Hume's method of order 3, right? But I will ask you, at least be prepared for Range-Kutta method of order 3 derivation, order 3 of order 4, because you must have been done Range-Kutta method of order 4, right? Probably just the formula with you, because she's asking in the 10th question to find the approximation using Range-Kutta method of order 4. So has it been discussed in the class?
यस सर.
So what I will ask you to at least try to be prepared about how to drive Range-Kutta method of order 3 at least. You must have done the derivation of those xi1 k1 plus xi2 k2, those sort of things, right? For second order, right? And then you must have found out some condition of xi1 and xi2 and different condition of sorry for the disturbance. Different conditions on xi1 and xi2 was leading to different forms, right?
यस सर.
So, but I don't think that the derivation has been done for Range-Kutta method for order 3 or order 4. So, in order to be clear and in order to be double sure while coming to the exam, please try to do certain calculation for Range-Kutta method of order 3, because it might stress you out if it directly comes in the exam. I don't think that ma'am will ask such difficult question in the exam, but if you are already done it once at home, then things will be simpler for you. The same procedure will follow. Instead of xi1 plus xi1 k1 xi2 k2, you will have xi1 k1 xi2 k2 and some xi3 k3. So at least she must have told this formula that your y of I plus 1 is equal to yi plus summation xi into ki, where ki will depend upon f of xi plus some say aih comma yi plus is a I minus 1, or say summation j running from 1 to I minus 1. So at least this formula must have been taught in the class for higher order problems. Is it so?
Yes, sir.
So if this is taught in the class, she can ask you for Range-Kutta method of order 3 to drive that formula. So what I will recommend you, if you guys have time with you, so try doing at least for third order Range-Kutta method. Okay.
Okay, sir.
And I think question number 10 is just direct application. You have the formula with you, you have to just put the values of h, x naught, y naught, and you can get the solution, right? Can you do question number 10?
Yes, sir. We shall try.
You have your k1, k2, k3, and k4 with you, right? You just have to substitute the values of all these things. You want to find y1, you have x naught to be 1, y naught to be 1, and h to be 0.1. Just substitute these values in k1, k2, k3, k4, and find y1. Okay. And as far as problem number 4 is concerned, I will try to find some explicit form for yn and we'll get back to you.
Okay, sir.
Okay, so I think it is already time and we shall stop here. So you guys can leave now. Or if you have any doubt, you can ask.